Hey everybody, so I hope you guys enjoyed your week off. I know some of you guys emailed me or sent me a message on Remind about making up missing assignments, and that's fine. Just make sure that you remind me to update your grade, because remember that I forget things. So just send me a message and I'll make those changes. If there's something wrong with your grade, also let me know. If there's an assignment you submitted and I didn't give you points for it, just let me know and I'll make those necessary changes. All right, lesson 18.4 is the next lesson. For this week, you have lesson 18.4 notes and assignment, and then I am giving you a 6-question quiz. 9-question quiz. I ended up adding 3 questions where you just have to write the trig functions for sine, cosine, tangent. So those 3 should be freebies. And then there's some review questions and then 2 questions off today's notes. All right. So again, don't forget I have office hours Tuesday through Friday if you need help. So on Zoom. So I'll be posting those links on Google Classroom. All right, lesson 18.4 is titled Problem Solving with Trigonometry. And the essential question says, how can you solve a right triangle? Well, you guys have worked with right triangles already. You guys use trig, sine, cosine, tangent, and you guys have used Pythagorean theorem. So today's lesson is a combination of strategies you've already learned. The learning objective says students will be able to use trigonometric ratios and the Pythagorean theorem to solve right triangles in applied problems. So notice that it says right triangles. And here's the it's the only formula we're going to work with. Please copy down the title, area formula for a triangle in terms of its side lengths. And make sure you write from here all the way to here. So pause the video so you can write it down. The area of triangle ABC with sides A, B, and C can be found using the lengths of 2 of its sides and the sine of the included angle. Notice how all 3 of the formulas have 1/2, and then they have little b times little c. The only letter that's not here is A, so then this is sine of capital A, because A, B, and C, capital A, B, and C referring to the angles. And then little a, which is across from big A, little b, and little c are all side lengths. So A, B, C. So look, BC times sine of capital A. If it says AC, what's missing is B, so capital B, sine of capital B. And here you have AB, you're missing C, so sine of angle C. So hopefully you guys see the pattern. All right, this triangle isn't labeled, so we can label it, or you can just use the strategy that I told you. So remember, it goes area 1/2 times the 2 little legs times sine of the included angle. So area, I'm going to write A equals 1/2 times the leg times the other leg times sine of the included angle, and the included angle is 142. So remember, if you don't have a scientific calculator, you can pop this into Desmos, and Desmos will give you the answer. So once you type this into the calculator, you should get approximately 4.6, and then because this is area, we have units, meters squared. Okay, let's do another one. This one doesn't give you the triangle, so I'm going to just go ahead and draw a triangle, D, E, F. And they tell you DE is 9, DF is 13, and angle D is 57 degrees. So again, area equals 1/2 times 9 times 13 times sine of the included angle. So if you work with 9 and 13, the included angle is angle D, which measures 57 degrees. And if you type that into decimals again, you should get that the area is equal to 49.1, and my units are inches, so inches squared. Okay, you guys try this one, so pause the video here. Alright, so hopefully you guys got area is equal to 1/2 times 12 times 15 times sine of the included angle, which is 34 degrees. And if you type that into decimals or your calculator, you should have gotten 50.3, and this is millimeters squared. Okay, this is the second type of problem we're going to have. So this is where we're applying based on the learning objective. It said that we're going to solve right triangles in applied problems. So this is an example of an applied problem. So the problem here, everything it says here is drawn out here for you. So a shelf extends perpendicular 7 inches, so perpendicular forms a right angle from a wall. So this is the wall, so perpendicular angle. You want to place a 9-inch brace under the shelf. So this is a shelf, so you want to put a brace under the shelf, as shown. To the nearest tenth of an inch, how far below the shelf will the brace be attached to the wall? To the nearest degree, what angle will the brace make with the shelf and with the wall? So this is a 2-question problem. So step A, or part A, is asking you to find BC. Well, this is a right triangle, so you could use Pythagorean theorem if you want, or you can use trig. I'm going to use Pythagorean theorem because to me that's the easiest. So the hypotenuse is my C value, and I'm going to make this my A and this my B. But remember, Pythagorean theorem doesn't matter who's your A or your B. So A squared plus B squared equals C squared. We said that the A value is going to be unknown, right? So A squared, or BC if you want to write BC, plus B squared, that's 7 squared, is equal to 9 squared. Well, 7 squared is 49. 9 squared is 81. When you subtract 49 from both sides of your equation, you get A squared is equal to 32, right? Yep. And then you take the square root of 32, and you should get 5.7, approximately 5.7. So that's my answer for BC. So BC is equal to 5.7 inches. We're going to need this part in order to find part B, because part B is now asking us to find angle A and angle B. So we said BC measured 5.7. Let me write that in before I forget. So now I have to use trig. So I'm going to write so I know my hypotenuse is 9. If I'm going based on angle B, I'm going to find angle B first. Actually, I'll find A first, since A is first. Opposite of angle A would be 5.7, which means this is my adjacent side. So it doesn't matter if I use sine, cosine, or tangent, because I have all the values. But I'm going to use cosine. So I'm going to write cosine of angle A is adjacent divided by the hypotenuse. Now I want to find the angle measure, so remember, when you're trying to find the angle measure, you have to get rid of cosine, because this means cosine of angle A. So to get rid of cosine, I have to multiply it by the inverse of cosine. So cosine inverse and cosine would cancel out, and I get angle A is equal to cosine inverse of 7/9. If your calculator doesn't have the inverse function of cosine, you can use decimals, And if you do this, the measurement of angle A will be approximately 39 degrees. So now, if this is angle A, not angle B. If angle A is approximately 39 degrees, because it's said to round to the nearest whole angle, and angle C is 90, how do I find angle B without using trig? Well, that's easy. We know that the sum of the interior angles of a triangle add up to 180. So that means that if I add up angle C and angle A, I'll get 129. So now what's left? Well, angle B has to sum up with angle C and A to 180. So if I do 180 minus 129, I get 51 degrees. So the measurement of angle B is approximately 51 degrees. Or you could use sine, cosine, or tangent to find angle B, and you'll end up getting the same answer. But it's up to you. Okay, you guys try this one. So this is your turn. Please pause the video and try it. For this question, C and D is asking you to use trigonometric ratios. So tangent 27 equals 33 over EF, or you can say X since you don't know the answer, or A. Another one is sine 27 degrees is equal to 33 divided by DF. The one you can't use is cosine, because cosine you're missing two side lengths. You don't know what EF measures, this part, and you don't know the hypotenuse, so you cannot use cosine. The only ones you can use are tangent and sine, okay? Because we only have one unknown. So if you make EF like your X, so tangent of 27 degrees is opposite over adjacent. So opposite is 33, that's why I wrote 33 on top, divided by the adjacent, and the adjacent we don't know, so that's why I wrote EF. But again, if you want to write an X instead of EF, you can, and then you can solve for X. So I'm going to cross multiply. 1 times 33 is 33. And this is going to equal X times tan of 27. But I want to solve for X. So the opposite of multiplying by tan of 27 is to divide. And if you type that into your calculator, you will get an answer of approximately 65. So EF, this one was EF. If you remember, originally I had EF. So EF is 65. So I'm going to go back here. Okay, if I use sine 27, I'll get the value for DF. So I'm going to go ahead and use that, or you can use Pythagorean theorem. A squared plus B squared equals, we don't know the hypotenuse. But I'm going to use sine 27. So sine 27, I'm going to write it down here. I'm going to write an X here instead of DF, but I know my answer is going to be DF, not X. Okay, write sine 27 over 1. Cross multiply. 1 times 33 is 33. And X times sine of 27 is X sine of 27. The opposite of multiplying by sine 27 is to divide by sine 27, since I'm finding a length. And if you take 33 and you divide it by sine 27, you'll get 73 meters. So X will be 73, but again, X is your DF. So that means that this guy measures 73. So meters. So we found the distance of EF, and we found the distance of DF. Hopefully you guys got this one. Okay, the last type of example we're going to have is one that asks you to find the lengths given coordinates. This one's pretty easy because if you notice, AB and BC are straight lines. So if you just count the units, 1, 2, 3, 4, that means that AB is 4 units long. And the only other one that you can count easily is BC, because this is a straight line. 1, 2, 3, 4, 5, 6, 7. So this one's easy. But now I have to find AC, and you can't count. So I'm going to go ahead and use Pythagorean theorem, because that's easier. So what I'm trying to find is the hypotenuse. So 4 squared plus 7 squared is going to be the hypotenuse squared. 4 squared is 16 plus 7 squared, that's 49. 16 plus 49 is 65. And if you take the square root of 65, you end up getting a C value of approximately 8.06. So this is about 806. That's your hypotenuse. Now, the question is not asking me just to find the side lengths. It's also asking me to find the angle measures. So now I'm going to go ahead and find the angle measures. So ready? I'm going to use, I want to find angle C first. So I'm going to, let's see, so, it doesn't matter which one I use, because I know all the side lengths. So I'm going to, you know what, I'm just going to go with sine. No, I'll go with tangent. I like tangent. Tangent of angle C, I'm going to find angle C, is equal to O over A. Well, what's our opposite value if we go based on angle C? So if we go based on angle C, this would be opposite. This is your hypotenuse, and this is your adjacent. I'm going to write this in green. Adjacent, opposite, hypotenuse. So opposite is 4 over adjacent, 7. I want to find angle C, so how do I get rid of tangent? You multiply by the inverse function of tangent. Remember, you always multiply by the inverse to find the measurement of an angle. And if you type this into your calculator, tan inverse of 4/7, you should get approximately 30 degrees. So if angle C is 30 degrees and angle B is a right angle, guess what angle A has to measure? Well, 90 plus 30 is 120, so this has to be 60. So the measurement of angle A is 60 degrees. If you didn't want to use tangent, you could have used sine. So sine of angle C is equal to O. I'm using C again. So O over H. And then you would multiply by the inverse function of sine. Right? And then sine with the inverse function would cancel, and you would get the measurement of angle C is still approximately 30 degrees. And if you didn't want to use sine and you wanted to use cosine, it would be the same thing. Cosine of angle C is equal to A over H. That's your ka. So A is 7, H is 8.6. 8.06. So then to get rid of cosine, you'd have to multiply by the inverse function since you're looking for the angle. And if you do that, the measurement of angle C will still be approximately 30 degrees. Hopefully I didn't confuse you guys with that. Okay, this one's the one that's way tricky because none of your lines are straight as in horizontal or vertically, okay? But we need to find the side lengths to the nearest hundredth. I want you guys to try this one, see if you guys can figure it out. So pause the video here. I'm going to give you a tip. You can use the distance formula to find the lengths. Or you can use Pythagorean theorem, which was what I'm going to do to find the lengths. So notice I ended up drawing 3 triangles. So I'm going to start finding the blue one. So I want to find what we were calling the hypotenuse. I need to find this length right here, which is FE. So 1, 2, 3, 4. This is 4. 1, 2, 3. 3 squared plus 4 squared is equal to FE squared. 3 squared plus 4 squared is 25. If I take the square root of 25, I know that the length is going to be 5. So my first length is going to be 5. Okay, I'm going to go to my green triangle, okay? So 1, 2, 3, 4. 1, 2, 3. Oh, this one's going to be the same thing. 3 squared plus 4 squared is equal to x squared. That's what I had before, so I'm still going to get another 5. And if you don't believe me, 3 squared plus 4 squared ends up being 25. And when you take the square root of 25, you get 5. So this one's going to be 5 also. Now I'm going to do the purple one. The height is 1, and then 1, 2, 3, 4, 5, 6, 7. So 1 squared plus 7 squared is equal to x squared. And this gives me 50. When you take the square root of 50, the square root of 50 is approximately 7.07. So I'm going to go back over here. 7.07. Okay, that's the side lengths. Now I have to find the angle measures. So ready? I measured over here. So right now I'm going to tell you guys, it doesn't look like it, but I'm going to tell you guys right now that this is actually a right angle. So the only way we were able to do the Pythagorean theorem and all that is if we have right angles. So I'm just going to tell you that's a right angle already. If you don't believe me, you can find the slopes, and you will determine that the slope of DF and FE are negative reciprocals of each other. And in integrated math 1, you learn that if you have negative reciprocal slopes, then they end up being perpendicular, and perpendicular means that they form a right angle. And so DF is perpendicular to FE. Okay, so I have to figure out if I want to use SOH as in sine, cosine, or tangent. And I'm going to go, this time I'm just going to pick sine. So I'm going to go based on D. So sine of angle D is equal to O over H. So my opposite value will be 5. And the hypotenuse will be 7.07. To find angle D, I need to get rid of sine. So the inverse function is what I need. Oops. To both sides. Sine inverse cancels out with sine, so I get D, angle D, or measurement of angle D, is equal to sine inverse of 5 divided by 7.07. And so if you end up doing that, you get 45 degrees. Well, if angle F is 90 degrees, and angle D we just found out is 45, what does angle E have to be? Well, 45, because 45 plus 45 plus 90 equals 180. All right, summary. You can use trigonometric ratios to find side lengths or their inverses to find angle measures. You can use Pythagorean theorem to find the third side length. All right, assignment 52, I don't know why in my textbook online it doesn't give me the student page, so please go to module 18.4, look for the homework page, and I want you guys to complete questions 1 through 11. This assignment, your notes, and the quiz will be due on Monday. I'm giving you a whole week. April, what would it be? 27th? I think. All right. So you have until Monday midnight to turn this in. If you have any questions, again, you guys can join me on Zoom. Office hours Tuesday through Friday. All right. Have a good week, guys.